Hello, everyone. Today we are starting water systems. This section focuses on water supply in buildings. Water for a building can come from three main sources: a water tower, a well supply, or a municipal water supply. When sizing water supply piping, there are 5 factors that determine the required pipe size: available water pressure, fixture demand, type and length of piping, height of building, flow pressure needed at top floor. Each factor affects whether fixtures receive enough water pressure. The first factor is available water pressure. This is the pressure provided by the street water main or other supply source. Street water pressure typically ranges from 45 to 60 psi. If pressure exceeds 80 psi, a pressure reducing valve is required. A pressure reducing valve converts high or fluctuating inlet pressure into a lower constant outlet pressure. This protects the building's plumbing system. The second factor is fixture demand. Fixture demand describes how much water a fixture uses during operation. Fixture demand is measured by flow rate, expressed in gallons per minute or GPM. Different fixtures have different flow requirements. The third factor is the type and length of piping. As water moves through pipe, pressure is lost due to friction. Pressure loss due to friction is the pressure variation resulting from friction within the pipe between the street water main and the water supply outlet where the water is being used. Flow resistance also occurs as water passes through valves, fittings, and changes in direction. Pressure loss due to friction increases as more pipe, fittings, valves, and other devices are installed in the water supply system. The fourth factor is the height of the building. Water pressure decreases as water is lifted to higher elevations. Water pressure in a water supply system decreases as water flows upward through a building. This loss in pressure is called pressure loss due to head. A column of water loses 0.434 psi for every 1 foot of elevation. Let's look at an example. If the highest outlet in the building is 50 feet above the water supply, we calculate the pressure loss due to head by multiplying 0.434 by 50. That results in a pressure loss of 21.7 psi. This pressure must be accounted for when determining whether enough flow pressure remains at the fixture. Flow pressure is the working water pressure at a fixture while it is open and flowing. It is calculated by subtracting friction loss and head loss from available pressure. Water supply must be provided to water closets with flushometer valves on the 6th floor of a commercial building. The available water pressure is 50 psi. The water supply piping is 2-inch copper tube with a total developed length of 200 feet. The pressure loss due to friction is 2.5 psi per 200 feet of pipe. The flushometer valves are located 65 feet above the water main and require 40 psi to operate properly. We will determine whether adequate flow pressure is available. Flow pressure is calculated using the following equation. Flow pressure equals available pressure minus the sum of pressure loss due to friction and pressure loss due to head. First, calculate the pressure loss due to head. 0.434 times 65 equals 28.2 psi. Next, add the friction loss of 2.5 psi. Now subtract both losses from the available pressure. 50 minus the sum of 2.5 and 28.2 equals 19.3 psi. Because the flushometer valve requires 40 psi, there is not enough flow pressure available at the fixture. This means additional design measures would be required to properly serve these fixtures. Flow pressure is calculated using this equation. Flow pressure equals available pressure minus the sum of pressure loss due to friction and pressure loss due to head. First, calculate the pressure loss due to head. The elevation difference is 65 feet, or 65 multiplied by 0.434 equals 28.21 ESI. Next, identify the pressure loss due to friction. The given friction loss is 2.5 psi. Now substitute these values into the equation. 50 psi minus the sum of 2.5 and 28.2. This results in 19.3 psi of available flow pressure. Because the flushometer valve requires 40 psi to operate, there is not enough flow pressure available at the fixture. this system does not meet the minimum pressure requirement for the flush-ometer valve.